Hello, 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 hello. Very good afternoon, good evening, good morning, whenever you are watching this lecture. Now, in the last two lecture, I have completed alcohol and phenol. Now, in this lecture, I am going to complete ether. Then this is the completion of the chapter called alcohol, phenol, and ether. First topic I am going to start, and the name of the topic is called method of preparation of alco sorry method of preparation of ether. First I will ask start method of preparation of ether. After method of preparation I will start reaction chemical properties of ether. Method of preparation of ether. First we will prepare the ether by the topic called dehydration of alcohol. Everyone knows कि dehydration means sir lose motion. Means dehydration means removal of water. So when you will remove water from alcohol, you will get ether. See over here very properly. Suppose I have written H3C CH2 CH2OH and I am going to react this one part and second part. Understood everyone very properly because all the things I have already dictated. Over here I will take concentrated H2SO4 and temperature I have taken 140 degrees Celsius, that is 413 Kelvin. Over here again I have taken concentrated H2SO4. Reagent is same, but I will increase the temperature as 170 degrees Celsius, that is 443 Kelvin. If you will take 413 Kelvin, then it will produce ether H3CCH2O and another mole of this CH2CH3. Means first the name of this reaction is called Williamson continuous ether. Don't say Williamson synthesis method. No. Williamson continuous ether, and it will follow SN2 mechanism. What is happening in this part? Na? First of all, you will attack H plus from concentrated H2SO4. It will become CS3, CS2, OH and H. H plus will come. It will go as a plus. Then another mole of CS3, CS2, OH will come here attacking, and then it will form ether. Understanding? So this is the mechanism behind it. Now, second, if you will increase the temperature, it will form alkene, CH double bond CH2. Now, over here, whenever you are producing ether, so you will write कि 1 degree alcohol and 2 degree alcohol not suitable. Sorry, 2 degree alcohol and 3 degree alcohol. 1 degree तो I have already taken. 2 degree alcohol and 3 degree alcohol not suitable, and by dehydration to produced ether. Again, don't get confused. If you will take 413 Kelvin, exact, say what happened at 400 Kelvin, na, fixed temperature. When they will ask the question, fixed temperature is there. This to I have just dictated the short form mechanism. You already understood what I am trying to dictate. Na? Over here, OH will come, this means you don't understood, I will write it again. Okay, I will dictate what is the mechanism going on in this part. Okay, sir. Okay. Ha. See over here. First, learn the reaction as it is. Not that much big deal. First of all, 413 Kelvin, it will do formation of ether. This is known as Williamson continuous ether, not synthesis method. It will follow SN2 mechanism. 2 degree and 3 degree alcohol is not suitable by dehydration to produce alcohol. But if you will take this and you have taken you have to produce alkene. You have to produce alkene, this as a product. Then 1 degree alcohol will give alkene, but they will follow E1 mechanism. 2 degree alcohol and 3 degree alcohol will also give alkene, but it will follow, over here E2 mechanism. Because E1 carbocation on 1 degree, how you will make carbocation? So E2 mechanism, and it will follow E1 mechanism. Means overall, just this is completion. Overall, whenever you will take alcohol, that alcohol will produce ether at 413 Kelvin, that is known as Williamson continuous ether, and that is follow SN2. Same at 170 Kelvin, it will, or 443 Kelvin, it will form alkene. If 2 degree and 3 degree alcohol is there, dehydration of alcohol will not happen to produce ether. But whenever we have alkene produced, so 1 degree, 2 degree, 3 degree, all will form alkene, but 1 degree will follow E2 mechanism and 2 degree and 3 degree will follow E1 mechanism. Understood? Now, ether mechanism, no need to see, but if you will see what happened, CS3, CS2, OH. First you will take concentrated H2SO4. H2SO4. It will give H plus. Lone pair. H plus will attack over here. You will get CS3, CS2, OH, H. It is plus. It will go outside. Plus will come. Another mole of CS3, CS2, OH will come. Lone pair attacking over here. CS3, CS2, OH. And where it has attack? CS2, CS3. It will, this part is here. It will go outside. This part is here. It will go outside and you will get CS3, CS2O, CS2, CS3. And alcohol is producing alkene, that already dictated in haloalkanes, haloarenes by dehydration of alcohol only. Understood na? That part you already know. Ki carbocation, if 2 degree, 3 degree is there, carbocation rearrangement, everything will there. If 1 degree is there, no carbocation, no rearrangement. So this part you already know. So this first topic, the preparation of ether from dehydration of alcohol, will be completed. I hope you understood it. Lots of things you know, so I don't want to waste your time. Second method is Williamson synthesis. First one is Williamson continuous ether. But second method is preparation of ether. Only two method. After that done. This is known as Williamson's ether synthesis. This method is called Williamson ether synthesis method to produce ether. Williamson ether synthesis method to produce ether. In this part, you will take ROR dash. It is the ether, na? This is the formula of ether. What you will do to produce this? Either you will take RO minus plus R dash X, or you will take RX plus O minus R dash. Means either OR will be there or this OR will be there. Anyone will be there. Now we have to understood ki which R will be there. Means I am saying either this will be 1 and X will be with this, or this will be 1 and X will be this. I am writing only that part, na? Ki either this you have taken OR and X will be here, or you have taken this as OR and X will be this R. Understood? So either this will happen or this will happen. Means what is the reagent required for this? You required alkyl oxide plus alkyl halide. Alkyl oxide plus alkyl halide, and it will also follow SN2 mechanism. And if you have studied E2 mechanism, over there also alkyl oxide you are using. So there is a chance ki alkyl oxide will do E2 mechanism also. So I am going to write one chart. That when it will do E2 and when it will do E1. So over here you will write, you will use base. Base will be RO minus plus RX, R dash X, suppose I have taken. Now this RO minus is base. R dash will be either 1 degree X, or R dash X will be 2 degree X, or R dash X will be 3 degree X, or R dash X will be something like this, CH2 double bond CHX, or benzene ring X, or some bridge carbon ringa chinga and X, or 3 degree. Now you know that these phenylic or bridge will not do. This will never ever do either E1 or SN2. This will never ever do either E1 or SN2. So this to moe, this to gone. I'm cancelled it, this to gone. Over here 3 degree R is there. If R is 3 degree, then it will do E2 mechanism, and the major product formed is alkene. If R is 2 degree, again it will do E2 mechanism, and the major product form over here is alkene. In E2, in R dash 2 degree, SN2 will also happen. In this 2 degree, SN2 will be also there, and it will form ether, but ether will be minor one and major one is alkene, and 99% cases they are asking major one. And if R will be 1 degree, always it is SN2 and it will form ether. This flow chart you have to be aware of. Whenever you have 3 degree alkyl, then E2, 1 degree alkyl, then SN2, 2 degree, then E2 also, SN2 also, but major will be E2, minor will be SN2, because alcohol oxide is used in the E2 mechanism also. Sir, we understood what you are trying to say. That, see, it is not that much complicated. Please see it very, very properly and try to understood. It is very important, very, very important to understood this part, and very easy, very, very easy. So don't get nervous and confused what you have written, sir, what you have written. Now some example over here. Now this flow chart you will have to know. Some example, suppose I will write CH3, CH2O, C, CH3, CH3, CH3. Now they are asking by which alkane has been formed. Means ether it is there. It is the structure of ether. Tell me which one is attached with X and which one is attached with minus. So one possibility you will take CH3, CH2O minus is there, and plus C, CH3, 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 and with this X is there. With this X is there. This will go with O minus and this will go with X. Or someone will say, no sir, I can take CH3, CH2, X with this, and C, CH3, 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 O minus with this. Which one is correct? Just now I have told you कि alkyl will be 1 degree. So alkyl is 1 degree. This is correct. This is wrong. So if you have to know the short trick you know कि 1 degree will get X. 1 degree will get X. X means chlorine, bromine or iodine. And other than that will get Y, means over here what you will get? You will get, suppose this question is there. So which one will get X? 1 degree will get X, 3 degree will get O minus. So this is the short trick. 1 degree will get always X, X, X. Suppose I have written second example. Sir, what will happen? What will happen? Suppose anyone is asking before example, what will happen if I will take this? This you have said wrong. If I will take this, what will happen? Take it. This you have taken X, and over here CH3, CH2, O minus, it will do E2. E2 it will do, it will go outside. It will become beta, beta and beta, and it will form alkene. It will not form ether. But already I have told you that ether is formed. Because once it will become 3 degree, it will follow E2. And E2 will form major product as alkene. Just now written a flow chart. So this you have to take care. Acha, okay sir. Suppose I will write second example. H3CO CH CH3 CH3. Tell me from where the ether has been formed. You will say कि 1 degree will convert into X. This is 1 degree, and 2 degree will go with alcohol oxide O minus CH CH3 CH3. Suppose I have taken third example. Ringa chinga O, ringa chinga pinga this. Sir, in this part, so this is also 1 degree, this is also 1 degree, but this is less bulky group. So less bulky group will get X, and more bulky group will get O minus. Understanding? Suppose I will take fourth example. Sir, in this part, ringa chinga pinga, O is there, ringa chinga pinga. Now tell me what is there. They will say no. This ether, this structure is not possible. because if I will take anything, this will become X and 1 will become ringa chinga pinga O minus, and this is never ever possible because ether required at least 1 degree, 2 degree at least. Ether will not form by 2 degree also. It over here to 3 degree, sir. Suppose I will write next example, pH O pH. What you will say, sir, 1 pH will get X and 1 pH will get O minus. Na kabhi nahi, na, it will not form because I have written na pH will never do, this part will never do the reaction. So that you have to take care. Understanding? हाँ sir, understanding. Suppose I have taken 6th example, PHOCH3. This you will say, sir, their name is anisole, and I can draw with this. What I will do? PHO minus I will take and CH3 X I will take because X required 1 degree or X required 1 degree. O minus to anything, no problem. Suppose I have taken 7 example. This over here O and this coming. Now what you will say? This will get X and this will get minus. No, not possible, sir. Either X is not happy with this also or not happy with this. So this will also not do reaction. So this will not do. Remaining you understood how to form ether. So this is all about the preparation of ether. Only two methods is there for the preparation of ether. Any problem means any problem, you can call message 9267937718 and trust me, I will dictate you over there properly. So we have completed the preparation of ether. Now we are going to see the ether is very smaller topic, so don't worry about it. Chemical properties of ether. Now we are going to see the chemical properties of ether. Preparation we have done. Now we are going to start the chemical properties of ether. Okay, sir. Now in chemical properties we are going to see only 2 is there, and that 2 we will see. First one is reaction of ether with HX, and second one is reaction of ether with H2O. Only 2 is there. Now over here what happen? You will take ROR. Either you will react with HX or you will react with H3O plus or H plus H2O. H2O written means what? H3O plus or H plus H2O. Anything you will take. Now over here what happened? H plus minus plus H plus is coming na, so H plus will come, RO plus H will come because oxygen has a lone pair R. Same thing happen over here, RO plus H is there, R coming. Now question arises ki where the X will go? This process is also known as hydrolysis. You know na, hydrolysis. Now question arises, which part the X will go, which part the OH will go, and which mechanism it will follow. The first case number 1. In case number 1, if you will get a stable carbocation R plus, how it will be stable? Either it will be 3 degree or it will follow resonance. It will do resonance. And over here OR plus and H, then you will break it from here. If this side, one side R will be something stable and one side R will be something like that. Stable is there, then you will break like this. Then after breaking what happen? One will give X minus because both has given already H plus. So they have to give X minus. One will give OH minus. Now, matlab H2O. X minus and OH minus. So plus will get X minus. So stable will get X plus. What is left over here? ROH. Over here, what happened? Stable will get OH, alcohol, and another one is also ROH. Understood? Okay, if you will break from here, this will become ROH, and stable will get X from this and OH from this for water. So I hope you understood what bakbas I am trying to dictate. So like that you will do. This is the question also I will do. Case number 1. Now in case, and this will follow, both will follow SN1 mechanism. Why? Because stable plus is there. So either X minus or OH minus is coming, but both will follow which mechanism? SN1 mechanism, means carbocation, everything you will do. Now case number 2 we will have. Case number 2 saying कि suppose this side you have 1 degree, OH is there, plus is there, and over here only CS3 is there. So what you will do? You will say कि sir, from where I will break, I didn't know. So in this case you will follow SN2 mechanism. In this case you will follow SN2 mechanism. Suppose I will give X minus or I will give H2O. What happened? Both will attach on CS3. Sir, what is the difference between 1 degree and CS? This will be anything, na? CS3, CS2, CS2, then after that OCS3, na? So this will be to anything we didn't know. So X minus or anything will attach over here, and this 1 degree will convert alcohol. So what you will get? 1 degree with OH here also, 1 degree with OH here also. Plus and plus. What you are getting? CH3 X, and over here you are getting CS3 OH, because it is giving OH minus. Means overall what you understood, कि this will follow, this 2 will follow SN2 mechanism. If 1 degree and methyl is there, if 3 degree, one place only 3 degree, what it is, no need to worry, always follow SN1. But if one side 1 degree and other side only methyl, so attacking will be on the methyl and it will follow SN2 mechanism. Now we have case number 3. Case number 3 is saying कि suppose this side you have 1 degree plus H that you have got, and this side you have 2 degree. Now you will attack over here X minus, there is a possibility, and you will attack over here OH minus, H2O. From H2O you are attacking OH minus. In this part what will happen? 1 degree, because 2 degree, so 1 degree will get X and 2 degree OH, means it will break from here. This total will become OH and 1 degree will take X. Over here what you will get? Over here you will get 1 degree OH. OH giving, na? So this will get OH and this total is 2 degree OH. But in this situation this will follow SN2, but this will follow SN1 mechanism. So that you have to take care always and always. Suppose I will write some question and I will don't want to repeat any topic 2 times, 3 times, because repetition will make more confusion. One time teaching, see again time, you will get understood the point. But if I will repeat, it maybe I will make you confused. So these are the cases that you have to know. Suppose I will write like this, and I have given over here concentrated HI. First question I will write. Now see over here with the question. Over here what you will say? Ki sir, it will follow SN1, 3 degree will get I and remaining 2 degree will get OH. Over here what happened? Same, 3 degree will also get OH, because it will break from here, a stable plus is there. The OH coming and remaining 2 degree will be also OH. I am writing only product. Over here, sir, which one will get I? This will get I. And the remaining OH, ringa, chinga, this will get. In this situation, OH situation, what happened? This will get OH and this will also get OH. Understanding what I am trying to dictate? Any confusion anyone have? No sir, we are understanding it, what you are trying to say. Okay. Now I have done everything correctly, huh? Suppose I have taken this example. What you will say? pH will get OH and CS3 will get X. See, always I am trying to give X or OH, giving, this will give OH minus, na? I am trying to give to a smaller one, always saying, na? If bigger one is there, then I will give bigger one also. See, 3 degrees there, then I will give bigger one. That you will see once. Over here I will break from here. Over here from I am breaking, here I am breaking. Over here from where I am breaking, here I am breaking. Over here we will break from, over here what you will get? pH OH plus CS3 OH, both will get OH. Over here you are able to break? No, any place you can't break, because pH X will not come. This part very important. From where you will break? You will say, sir, In this situation, I have option to break from here and to break from here. But I will break from upside because here breaking is not looking good. Why not looking good? No, one second. See, over here, what you will do, sir, in this example, I will say from where I will break it from here. And what I will get? Ringa, chinga, stable carbocation, resonance also. This, it will get I plus this side. From where I will break, sir? From here I will break because minus sign is stable by resonance. It will get OH. Understanding what I am trying to say? Similarly, in this case, what you will get? Ringa, chinga, it will get also OH. It will get also OH. After that, you will remove water, no problem, and ketone you will form, but ketone is not forming over here. Plus outside, this will give what? You are breaking from here, OH, and this will give what? Ringa, chinga, I on the bottom side. Here, OH, here, OH. Understanding the point? Over here, from where I will break? From here I will break. What I will get? This side, OH, and this 3 degree will be I. And over here we are getting this side, OH, and this is also giving OH. So this is OH. So I hope you understood it. See once what I am dictating, right? See, from here you will see case 1, case 2, case 3, what I have written, how I have break it, how I am writing the answer, that you will see. Stability I am checking simply. I am checking which plus is more stable and how I will check the stability over there. So check it, once revise it, and this is all about the completion of ether. One small topic is there that I will dictate over here, very small, that is called physical properties of alcohol, phenol and ether. Physical properties of alcohol, phenol and ether. In that physical properties of alcohol, phenol or ether, first of all we have to know about boiling point. You know that boiling point is directly proportional to hydrogen bond, and hydrogen bond is directly proportional to number of OH molecules, because alcohol, phenol will contain OH, ether will not contain. So alcohol, phenol has more boiling point than ether. It means more is OH, more is the boiling point. Then boiling point is directly proportional to molecular weight. This also you have seen. And boiling point is inversely proportional to branching. Sir, this to we already know. How many times you will teach us this? No problem, I am just teaching. Second topic, they will ask about stability. Again, stability is directly proportional to hydrogen bond, that is directly proportional to number of OH, how many OH is there, and stability is inversely proportional to number of carbon. Why? More is the carbon, so it is not soluble. Stability saying, sorry, not stability, solubility. Solubility in water. Solubility in water. The more is the number of carbon, it is less soluble in water, and less is the branching. So everyone is at one place, so more soluble. If less branching, more soluble. So I hope complete. Now method phenol already I have completed. So I hope everyone understood how I am doing it. Once see 2 times the ether, and I hope you will able to understood. If not getting, na, seriously I am saying, see one more time. This will make you happy to understood. Trust me, this will happen with me also. Suppose I am reading something one time, not getting, one more time I will read out, it will automatically strike. Don't say, sir, overall 90% of the students saying, sir, we didn't understood, so we don't want to see online classes. No. You will just see once, not coming 2 times. Now you have to prepare for JEE, so at least you have to sacrifice na, and giving the 2 times time. Na. Understanding the point? Na? Haan, sir. So 1 time not coming, 2 times see. 2 time not coming, 3 times see. But try to understood. Still not coming, ask me, I will dictate you everything in WhatsApp number I am already giving you all. So bye, have a nice day, enjoy, take care, stay home, stay safe.